Hey guys, I'm Jonas with PowerEquipmentMan.com. Today we're going to be installing this lithium battery in our Yamaha Drive 2, and I'm going to be giving you some real-world data about the pros and cons of installing lithium in your cart. Today we're working on this 2021 Yamaha Drive 2 AC electric cart. Now we're getting ready for this cart to be resold, and it still has the original lead acid batteries in it from the 2021 model year. Now when we're reselling carts here, if anybody's buying an electric cart, chances are they don't want lead acid batteries, and they definitely don't want 5-year-old lead acid batteries. So we have to upgrade all of our electric carts that we're getting refurbished to resell with a lithium battery. Now, fortunately, the guys over at BattLite reached out to us about trying out their brand new lithium battery. Now, this battery that we're going to be installing today is their 51 volt, which is a replacement for a 48 volt cart. And this one is rated at 100 amp hours, which is going to be plenty of juice for anything that our potential customer is going to want to be able to do with this cart. Now, this should be a fairly simple drop-in replacement. With this order, we got the battery along with the digital meter to go in the dash, and we also got the mounting brackets for the Yamahas to make it fairly simple to install in this cart. We also got the charger and charger receptacle that we're going to be installing on board on this cart as well. So we'll be able to make this a pretty quick and simple battery swap. Now, before we did this battery swap, I wanted to get some data to actually be able to compare the lead acid batteries to our new lithium battery. So we did some testing with the cart in its current condition just to see what results we got. So we did a distance test to see how far we could drive on a fully charged set of batteries. And we also weighed the cart and did some performance testing to see acceleration wise how fast the cart was, what our top speed on the cart was. So we want to be able to compare those numbers from before to what we get after we install this battery. So if you stick around till the end of this video, we're going to be going over all that data and how the lithium actually performs compared to our old lead acid batteries. Now that we've got all that data that we need from our lead acid batteries, we're going to go ahead and get this lithium battery installed in our cart, and then we'll run all those same tests again. Now, the first thing that we're going to need to do is to get our old batteries out of the way. Now, before you start working on an electric cart like this, the first thing that we're going to do is flip our run tow switch to the tow position, and we've got the key turned off, removed from the ignition. You do need to be careful anytime that you're messing with electricity like this. Now, when we're disconnecting these batteries, the first one that we need to disconnect is our main battery pack negative. So this one right back here on this setup is our main negative. So we're going to disconnect that, followed by the main positive, and then we can start disconnecting the individual batteries from each other, remove our battery cables, the watering system on this, then we can remove our battery hold downs as well, and then we'll be ready to actually pull the batteries out of the cart. Now, while we had the batteries out of this thing, we went ahead and power washed it to get it good and cleaned up. This is the perfect time to get it clean before we install that new battery. Now, before installing this new lithium battery, I went ahead and bolted the mounting brackets onto the bottom of it. That would just help save me extra times of having to install and remove this battery. So with those brackets on there, I went ahead and set the battery down into place, and then I had to play around with it a little bit to figure out what was going to work best as far as our power and ground cables for the cart itself. Now, I figured out that if we place the battery with the terminal side underneath of the driver, then we could do a little bit of rerouting with our power and ground cables here and be able to make our original cables work. Now, to get our power cable to work, it originally is on this side of the cart. I was able to loosen it on top of the starter solenoid. Now, once I spun that cable around, I was able to drill out a hole that was already in the frame and run that power cable through that hole, and it ended up being the perfect length to reach this battery. Once we were able to figure that out, I went ahead and marked the holes for the mounting brackets on the battery, drilled out all 4 holes, and got the battery bolted down. Now with our battery bolted in where it needed to be, I went ahead and mounted our charger so that we wanted to be an onboard charger for this setup. So we just used a couple of self-tapping screws to bolt that charger into place. And I also went ahead and installed our charging port. So I wasn't able to use the factory mounting holes, but I just used a couple of self-tapping screws to mount that port into place. Now that charging port is going to be really handy, so that way you can easily plug and unplug this thing without having to raise the seat. As long as you've got a nice heavy-duty extension cord, you can charge this cart from anywhere. Now we're ready to go ahead and bolt on our cables to the battery. So we had made sure that the battery was turned off, and I always do our positive first. So we connected the charger positive cable and then the positive cable from the cart itself, bolted that on, and then we connected the same thing on the negative side. Then we connected the cables for our remote on-off switch and for our display in the dash. Now to install this gauge in the dash, we just used a 2-inch hole saw to cut a hole in the dash and then bolted that gauge into place. Now overall, this installation was super simple. There really wasn't anything special that we had to do to make this setup work. It just took a little bit of figuring out to be able to run our cables and where we were going to mount our charger and the charging port, and we were able to install everything fairly simple. The only extra thing that we had to have was a couple of self-tapping screws to mount the charger and our charging port. But other than that, everything that we needed was either included in the kit or we reused the original. Now that we've got everything installed in the cart, we're ready to go test this thing out. So we finally got finished up with all of our testing with this new battery installed, and we're going to go over the results with you of what happened between the change from lead acid to lithium. Now, one of the first things that you'll notice when changing from lead acid batteries to lithium is going to be the difference in weight. So in this particular situation, we ended up dropping about 255 pounds of weight. Now, for our next test, we tested the distance, how far that we could go on a charge. So what we did was charge the cart up to fully charged. We checked all of our tire pressures, made sure they were at 18 psi. We had the windshield folded down the whole time, and we drove the cart until it went dead. So basically, with the lead acid batteries, we drove it until the cart stopped. When the batteries got low enough, they hit a certain voltage cutoff point, the cart actually beeps at you and then shuts down. And then to get it to go again, we had to flip the run tow switch, turn the key off and on, and the cart would finally take off and go a little bit farther before it shut down again. So that was on the lead acid batteries. On the lithium battery, I did reach out to the manufacturer and ask them what a safe discharge level was. I have heard that with lithium batteries, some of the manufacturers don't want you to go below 30% or below 20% charge. So we talked to the manufacturer. They did say 20% was a safe level. Now, we did find out when we actually got down to 20% that once we got to that point, the battery actually started beeping at you. So the battery was telling you that it was discharged and needed to be recharged. So on the lithium battery, we ran from 100% down to 20%. Now, the first thing I want to go over is the recharge time. So after we discharged it, we used a meter that we plugged into the outlet and then plugged our charger into so that we could charge how many watts the charger was pulling while it was recharging, and then how long it took to recharge those batteries. And based off of that information, how many kilowatts of power that it used, and then we could determine the cost of what it cost to recharge that battery. So the lead acid batteries took 7 hours and 25 minutes to recharge, while the lithium battery took 5 hours and 37 minutes. So not quite 2 hours faster recharge time. Now, the lead acid battery drew a maximum of 1,025 watts while it was recharging, where the lithium battery only drew 895 watts. Now, the lead acid batteries used a total of 6.1 kilowatts, which at our cost rate here, we use 20 cents per kilowatt to determine how much it actually costs to recharge those batteries. So we used about $1.22 worth of electricity. Now, on the lithium battery, it took 4.78 kilowatts and cost about 96 cents. So since it took less watts while charging and was a shorter charging time, it ended up costing less money to recharge. Now, voltage wise, when we started out with the lead acid batteries, we had 51.0 volts. And when we got done, we were at 48.31 volts. The lead acid battery, we went from 53.2 volts down to 52.2 volts. So we only dropped about 1 volt with the lithium setup versus a 3 volt drop with the lead acid. Now, as far as runtime goes, with the lead acid batteries, now I want to remind you, this was the original lead acid batteries that are exactly 5 years old this month. The original, they're the Trojan T875 batteries. So those original batteries went 23 miles, which completely blew my mind. I thought we were going to be in the 10 to 15 mile range from everything that I had read online, especially being 5-year-old batteries. So I just could not believe that we went 23 miles on those original 5-year-old lead acid batteries. Now we had a total of 1 hour and 25 minutes of actual moving time, so not counting any stops. We were 1 hour 25 minutes, top speed of 20 miles an hour, an average speed of 15 miles an hour. Now with the lead acid batteries, I thought that was a pretty good runtime. With the lithium, we got a total of 34 miles, 2 hours and 4 minutes of moving time, top speed again of 20 miles an hour, and an average speed of 16 miles an hour. So we were driving the exact same route. The route that we were using was pretty much just flat ground. We don't have much for hills around here. A lot of long straight runs. We did have, plenty of stops and starts here and there every time that we came up to an intersection or something, but it was a lot of long straight runs. But that's about as good a conditions as you could get for testing a battery, where you're not dealing with a bunch of stuff that's going to put a lot of draw on that system, just being on mostly flat ground. The only thing that I can think of why our average speed was a mile per hour faster was just because the cart was lighter and we were getting up to speed faster. So it was holding a higher speed for longer. Now, the next test that we did was with a draggy. Now, if you guys aren't familiar with what a draggy is, it's commonly used by guys that are doing race car stuff. So basically, you have a way to use your phone and a little box that you mount in your vehicle to be able to accurately track your, 60-foot times, 330 times, quarter mile times, so you can see if you're making changes to your vehicle, how fast you're actually accelerating. So we use that with the cart to be able to see if we gained any acceleration when changing from the lead acid to the lithium. So the numbers that we recorded were going from 0 to 30 feet and 60 feet, and then also mile per hour going from 0 to 19 miles per hour. So how long it took us to get to each of those stages. So our 30-foot time with the lead acid batteries was 2.41 seconds. With the lithium batteries, it was 2.40 seconds. So not much change, was just a touch faster. Our 60-foot time, we went from 3.70 to 3.63. So didn't pick up quite a tenth of a second there. Our biggest change was going the 0 to 19 miles an hour. So when we actually hit our top speed, So we went from 4.87 seconds down to 4.29 seconds. So pretty good pickup there, almost a half a second, or actually just over a half a second, just in. I think a lot of that came from the weight reduction. You know, we lost 255 pounds of weight, but your voltage is going to come into play there too, where in theory we were holding a more consistent, higher, steady voltage. Um, but if you'll notice, our top speed didn't change. So, you know, a lot of people do report that when they change from lead acid to lithium, that they pick up some top speed. Well, on this particular cart, the way that these are governed is by motor RPM. So it really doesn't matter that we lost some weight or that we gained a couple of volts. We're governed by how many RPMs the motor is turning. And this cart has been sped up, the factory upgrade speed code. But we hit 20 miles an hour with the lithium and we hit 20 miles an hour with the lead acid. Nothing changed as far as our top speed went. Now, to kind of break down these results and what my thoughts are as far as changing from lead acid to lithium, you know, honestly, with this particular battery and what retail pricing is on it, if we were to have replaced those original lead acid Trojan batteries with another set of Trojans versus replacing them with this particular lithium battery, honestly, there's not a lot of difference in cost. To buy a good set of Trojan T875 batteries, you're going to spend a pretty good chunk of change. You know, it wouldn't surprise me for you to spend $1,100, $1,200 for that set of lead acid Trojan batteries. Now, comparing that to retail pricing on this new lithium battery, this is a little bit cheaper battery than the normal Roy-Pow battery. There's not much difference, only a couple $100. And if you look at the lifespan of those batteries, so if these lead acid batteries are at 5 years now, they're still in pretty good condition. You know, I wouldn't be surprised if we could get another 2 or 3 years out of these batteries. So say we got 7 or 8 years out of a good set of lead acid batteries, and these lithium batteries are supposed to run 10 plus years. That cost difference of a few $100s, if you break that down on a per year average, what those batteries cost you, whether you're going to have the lead acid batteries for a shorter time period or the lithium for a longer time period, it really ends up being about the same cost. And the lithium may actually even be a little bit cheaper than the lead acid, just depending on how many years you actually get out of it. Now, the other thing we talked about, the weight difference. So having less weight in your cart is going to be easier on your cart. It's less wear and tear on your suspension, on your tires, your steering, even your brakes. You know, a cart that weighs less takes less braking power to be able to stop it. So having less weight in your cart is definitely going to be beneficial. One drawback to that less weight is this cart was built to handle the weight of those lead acids. So when we lost that additional weight, the suspension is just a little bit too heavy duty now for the battery that's in there. So it did make this cart ride a little bit rougher. Now, the easy way to fix that was to just lower our tire pressures. You know, really on a gas-powered cart, we only run those tires at about 12 psi versus an electric cart is so heavy, we have to run those at 18. Well, if we just let these tires down to 12 psi where we run the gas carts, that significantly improves your ride quality. So just by dropping tire pressure, we could help make this cart ride a lot better by losing that weight difference. Now, your other big advantages are going to be, as we mentioned, the cost to recharge it. So it doesn't sound like much, being 25, 26 cents cheaper to recharge it. But if you take that over every day, if you're somebody that drives your cart a lot or a couple of times a week, and you start adding that savings up, you are going to save some money on just the power that it takes to recharge this cart. And you're driving longer distances on a charge, so it's not going to need as much recharge time if you were to drive it 5 miles with a lead acid battery compared to 5 miles with a lithium battery. That recharge time is shorter. So you're going to save a little bit of money as far as the cost to recharge. Now, the other big difference, in my opinion, is maintenance. Now, that's the reason that a lot of people want to buy an electric cart, is because it's low maintenance. You don't have to change oil on it like you do a gas cart, or air filter, spark plugs, drive belt, any of those things that you would do to a gas cart, you don't have to do with an electric cart. But if you have lead acid batteries, you do have to check the water on those batteries at least once a month is what's recommended. So to check the water, you have to remove the caps and check your water level and add the distilled water, unless you had some sort of a battery watering system like this cart had on it, which is a little bit simpler, but it still has to be done. Those batteries have to be maintained. And then you're also going to get corrosion. So you've got to keep your terminals cleaned and coated so that you don't get corrosion on those terminals. Another big issue with the lead acid batteries is if a cable gets loose. When they get loose, they generate heat and it can melt the post off or damage the battery. We actually had this happening on this card. It didn't cause an issue, but when we went to remove them, after our long test drive actually, is when I noticed it, that one of the cables was getting really hot. And I actually put my temperature gun on it and it was 150 degrees. Because that cable was just a little bit loose, not even enough that you would have ever noticed it had I not touched that cable and felt how hot it was. But that's really not an issue that you're going to run into with a lithium battery. So overall, just those pros and cons, going to a lithium battery, less maintenance, longer runtime, cheaper to recharge. It really does make a lot of sense to change to a lithium battery. Now, I wouldn't say that this particular battery is going to be a real commonly used battery if you're doing a performance style build. If you want a cart that's going to run 30 or 40 miles an hour and you want to put a controller and a motor in it and really make a high performance type cart, this probably isn't the battery that you're going to buy. But if you're on a fairly standard cart, even if you've got big tires and wheels, but you've just got stock motor and controller, this battery is going to be a perfect option for that, and a very affordable alternative to some of the more expensive batteries out there. Now, if you guys are interested in checking out these batteries, you can take a look at them on the BattLite website, where they've got all the information about the different batteries they have available, as well as the different mounting brackets to fit your specific cart. Well, that's going to wrap it up for today, guys. If you got some good value out of this video and you appreciate the amount of time that it took for us to do this test and actually drive this cart until it went completely dead, please hit that thumbs up button. Consider subscribing. Thanks for watching. Have a great day.